Greetings, my fellow geothermal students. Once again, this is Jonathan Bowe here. We're already into week 4 in your topic 4. And hopefully you took a look at last week and you saw that we had the quiz and the tectonic plate and the smart geothermal. There was a quiz there that opened up for you on last Wednesday, I'm pretty sure. Let's take a look at it here. Okay, we've got one attempt so far. That quiz opened up Wednesday, September 14th, and it's due to close November 9th. But a lot of times, if we have some late sign-ups and people are not getting the quizzes done, then I'll extend that closure. But the question has been posed, how do I know what answers were right or wrong for my second attempt? Well, that'll become available to you once we close the quiz, once the quiz closes. That information will become available to you. So let's take a look at last week. We didn't get a chance to finish up on our Earth's core. Then we looked at the geothermal energy association, which is a real important part of your exam for last week. So if you haven't taken that exam yet, make sure that you note this website right here, and this gives you the opportunity to look at the Geothermal Energy Association, the professional organization, and you can look at the GEA itself, membership in the GEA, and as far as jobs are going, where you can go, news and media releases, the geothermal basics, like we're going to talk about different systems. You can look in your textbook, you'll see those, but here you can have it all under one roof for you. And then the actual resource maps. So let's just take a quick look here at the geothermal, the introduction that these guys have. So Gary, your question was temperatures, and this is a thermographic representation of the United States. And you can see here 325 degrees centigrade is purple. Look at that, right there at Yellowstone, huh? So all the way down to 25 degrees centigrade. Don't see much of that blue. But you see these are 6 kilometer depth temperatures. So if you've gone down 6 kilometers to acquire these temperatures, so you had to drill a pretty deep hole. But pretty much anywhere in the United States at this depth, you're getting 100 degrees centigrade plus, so 212 degrees Fahrenheit, enough to boil water. But then you got to remember that you have to get it to the surface before you can put it into a turbine or into a production generation of some sort. So this is just the United States in general, and you see that most of our resources, our hotter resources, are in the western United States. And this is directly applicable towards your quiz. One of the questions might be, in the western United States at 6 kilometers, the heat resources might be true or false, 75 degrees centigrade. And then you have to figure out, wait a second, maybe I need to go take a look in geothermal energy, take a look at a thermographic map of the United States. So it doesn't have to be this one, but this one's available to you right in your course. So if we go back and take a look at the course again here, in all these lectures that I give you, there'll be an overview like we see up here. And by the way, guys, let me get rid of it so it looks like a student view for you here. Let's do that real quick. So the question was posed, when we're taking these quizzes now, where's this, what information, specific information is going to be involved on these quizzes? Is it going to be more in the textbook, or is it going to be out of off the internet here, out of the course, the Moodle shell that you see in front of you right here? And 75% of the questions will come out of the Moodle shell, which you see the special topics, Introduction to Geothermal Energy Systems, 291.51. And then in that, another 25% will come out of the textbook, A Smart Guide to Geothermal. So the Smart Guide to Geothermal is a great reference for you to have when you're, as far as your lab is concerned, and as far as just walking around trying to install geothermal systems at your house or if you decide to get into contracting. But as far as where geothermal energy comes from, and how is it produced, the Earth aspect, the core of the Earth's inner and outer cores, like we see right here. This is all right here in your central column of your Moodle shell. So 75% of your questions are going to be right here. And you see that we had this quiz right here, tectonic plates, smart geothermal. And this is what you would see as a student now. So you get 2 attempts, and it's you have 2 attempts to complete the quiz. I'm sure that, and I think I took the time limit off of that. Yes, I did. So you can do it twice, and there's no time limit on you. So you can take the quiz if you feel weak. You look at your results and you go, wait a minute, not happy with what I did there. Go back through and find your weak questions. Go into the central column of the course, into the central column of your Moodle shell, and find out where that energy or information might be. And a lot of that information for this quiz here, the tectonic plate smart geothermal, a lot of that information is going to come out of your GEA, or Geothermal Energy Association, that we looked at here. And then within that, you see the topics up here. Not so much GEA events, honors, the professional aspect, membership, but if you want to get a job in geothermal, this is a great resource. But as far as our geothermal basics, which this is an introduction to geothermal energy systems, and then you get into just your basics. What is geothermal energy? Right here. What is geothermal energy? Well, see right here, the temperature in the Earth. Temperatures in the Earth. And we're going to see some video in this course where, especially in Europe and in England, where some of the residential applications, the guys their English seem to think that the sun has a lot to do with geothermal energy, which it's only about 2%. So the insolation, or the sun shining on the Earth, insolation, I-N-S-O-L, not insolation like you would have in your roof, but insolation, the shining of the sun on the Earth's surface. Insolation accounts for about 2% of Earth temperature. So the Earth comes from the core, or the heat comes from the core of the Earth. 2,000 degrees plus down there. So it's hot.
Is the core of the moon hot?
Good question. The question was, is the core of the moon hot? I don't think it's, that's a good, I'm not sure.
And how do we know?
Well, that's a great question, Gary. That kind of gets my brain fired up a little bit.
Could we make a geothermal heated station on the moon, use geothermal from the moon itself to airport?
I think that the core of the Earth is larger than Mars, basically, the outer core. So the moon being such a small body, I think that the gravitational pulls is necessary to create the pressures for the heat like we have on Earth at the core, because of the pressures and the isotopic degradation associated with the core of the Earth. So it's like an atomic reactor.
So what's the isotopic degradation?
Yeah, well, it's uranium breaking down. So it's basically atomic reactions, or fission things.
Creation generates what?
Yeah, it's the molecules, the atoms coming apart and creating heat as they separate there. So it's like a little.
There's more mass coming out of the equation than there is going in.
Yeah. Right on, Gary.
So it's a mass imbalance.
And see, and that would apply directly to your quiz in week 2. I know there's a question in there on, maybe it's a multiple choice question, and do be aware that some of these multiple choice questions, you might say, okay, that choice A, choice B, choice C, and then choice D, all of the above. Well, if all of the above apply, D is the best answer. So, even though the other answers are all correct, the best answer is all three of them. So don't get caught by that one, okay? But that way you get a little more information. They're pretty simple. The questions are pretty simple. But another big important part of this is, what is
Maybe
base load?
A teacher like you, with your credentials, teaching Ramada over there,
Hmm.
the best teacher in the league, everybody gets 100%.
Yay, sweet. Carrie's saying everybody gets 100, and then I get the big kudos.
Teachers are right. Forbes magazine's going to feature you on the cover.
Sweet, man. Let me do this real quick. So we do want to see what the Earth's geomagnetosphere, or the magnetosphere, does to help protect us from...
Soon the Earth will turn in harmony with the cosmos. But not necessarily in harmony with our star. The sun is sending us ominous warnings that we ignore at our peril. A roiling deep within. Energy building in its outer zones. An eruption gathering force.
If you look at this, so you can see the CME here, the coronal mass ejection, and the plasma coming off the surface of the Earth, but these convective cycles in the plasma are reflective of what we see in the atmosphere of our Earth.
An eruption gathering force. We are getting better and better at reading the flare-ups, the waves, and the spots that emerge on the solar surface. But our increasingly technological society has exposed us as never before to the sun's angry moods.
So an element of geothermal energy that is neglected is the magnetosphere, and we're going to talk more about that in topic 5 and 6 later in the course. But just so that you know, the Earth's core is the source of geothermal energy for the Earth. And about 2% of the geothermal energy comes from the sun, or insolation. So if we didn't have the magnetosphere, then the sun's solar wind would destroy the Earth. And this was just kind of a theatrical rendition of that the incoming solar wind is just blowing, using the power grid like a giant solar collector and overpowering all of our infrastructure. But at your leisure, do take a look at the attack of the sun. Attack of the sun. Okay, let's slide on down into topic 4 now. And we're going to start looking at our median Earth temperature lab, what we're going to do. And then a couple different things. I want you to be ready to download your Google Earth and USGS real-time earthquakes and Iris earthquake browser. And then we're going to look at tectonic interface, tectonic plate boundaries, and a geothermal heat pump. Now, the question was, what reading will we have? Look at the smart geothermal right here. Please open up your textbook and read through chapters 4 and 5. There will be a quiz on how to harvest Earth's free energy. So this is not a quiz, this is just an assignment. So then if we get back in here now, and this quiz is going to open up Thursday, I'm thinking. Let's see. I think it's head there. Thursday, yeah, September 22nd, 4 p.m. Quiz opens up. And this one doesn't have a closure on it at this point because of the new students that are enrolling, and I want to bring them up to speed before I start closing any quizzes out. And once again, you'll have this one, was it, how many attempts was it at? 20 questions, open book. Okay, so it looks like 1 attempt, and there's no time limit on it. So, well, 2 attempts, 2. Yeah, 2 attempts right there.
2 hour time limit.
Oh, there we go. Yeah. 2 hours on the time limit. Okay. So, we, what I would say is, if, also make sure that you save. These are paginated such that there's one question per page when you start into the quiz. So when you take the quiz, and if you're going to go off and do some work, maybe your computer will shut down, or maybe you lose your connection, and then you might lose those questions, and the clock keeps ticking. So save. Every time you answer a question, save it, so that if something goes wrong, you can come back and get right into it without, but you get 2 attempts at it. So, but you have to do it within 2 hours, so roughly 1 hour per attempt. But I'm guessing that it'll take you about 20 minutes for the first attempt, and then you can come back, find your weak points, go into the central column, find the information, and get 100%. Now in topic 4, it's starting to get exciting now, because here's our median Earth temperature lab. And guys, let's take a look here. This assignment. So you would click on this, and then it would open up your median Earth temperature lab. Just something that a little trick that I enjoy is that when you click on it, if you'll open it in a separate tab, if you just right click on it, you can open it in a new tab, and then it's going to save you some time going back and forth. So let's take a look. Our median Earth temperature lab. The median Earth temperature. Whoa. Now is the time to start your experiment. Let's make sure that we're going here. We're not, huh? Oh, okay, cool. Now is the time to start our experiment to determine median temperature in your selected site. So what you need to do is find an area that's accessible to you, where you can dig a hole 6 feet deep, or you could use a well casing. If you have a well in your yard, you can just take the top cap off your well, lower a string, depending on how far the well casing comes above the surface, but you want to get 72 inches below the soil surface, and place a remote temperature sensor at 72 inches below the soil surface. Okay, you could also use, you could go down in your basement, and if you walled off an area, you could get down at the bottom corner of your basement where there's not airflow, and you could put a little box over your sensor if it's 6 feet below the surface of the soil. But you have to keep it so that it's shaded, and so that there won't be air blowing over it. So, and likewise, if you put it down in your well casing, you need to cap that well casing off so you don't get external air temperatures affecting your results. So, placing your remote sensor, it's in a shaded, protected area. Now, you're going to get different results if you're on a real steep slope. So if you're on a south-facing steep slope, let's say, I would say 2% slope is probably about max, but if that's all you got, that's what you got. So try to find a relatively flat spot, and if it's shaded, that's fine, but it doesn't have to be.
This experiment?
Yeah. This is a lab that you can do. Now we're also going to do a rendition of this starting tomorrow, and I'm going to send you guys an email on this so you have that information in front of you.
So we're going to have to buy a post pounder?
No. If that's how you want to do it, you can pound a pipe.
This is OMEL USB is suggested.
I don't know if you can hear Gary or not. He's saying, okay, we're going to have to pound a post. Well, the other options were use an existing well casing or a drainage pipe, or you could dig a hole. And if you got nice soft soil, 6 feet is deep. So if you got shoulders at all, trying to dig a 6-foot hole, it's going to be probably 3 feet wide at the top. It looks like a little open pit mine or something by the time you get to 6 feet. So digging a 6-foot hole is not that easy, unless you happen to have an uncle with a backhoe, one scoop, and he's just about got it. So, or you could pound the pipe. But I would use an existing well casing or a drainage pipe, or put it down in your basement. But now the OMEL USB, that's a programmable sensor, so you could get up to 72 readings for a 24-hour period, which is too much. And we're going to talk about the data must be recorded consistently. And you can do that, you can go to Costco or something and get an indoor, or to Ace Hardware, or take an indoor-outdoor thermometer that you already have at home and put your sensor down in the bottom, and make sure that you have reception. If it's in a well casing, some of the cheaper ones won't make it. Or the best ones are ones with a little copper tube on them. And you just lower it on down in there. You lower it 6 feet of copper tube down in there and let it hang. And then you've got your both readings right on that one face. So you could just have a little indoor-outdoor thermometer. And then that tells you, if it's recordable, you can have your highs and low temperatures, like the cheapo weather station that I got from Costco for $20 or whatever. It has the highs and lows at external temperatures. So if you have your external sensor in the bottom of your 72-foot depth, then you're going to have your readings for that 24-hour period right there. You don't have to do anything. You don't have to go out there at 8 in the morning and do it, at 8 at night and do it. If you're most of them have that high and low for the day, so it's pretty cut and dried. If you have a manual, you need to go, set up a log book, and you need to go out and write down in the log book. So, 8 a.m., 8 p.m., it's good to have a 12-hour spread. And maybe 8 o'clock is not the best. I mean, the perfect one would be high and low. It would probably occur closer to, 1 or 2 in the morning for a low, and the high would be 5, 6 o'clock in the afternoon. It would be your air temperatures. But if it's automatic, you just go out every day and write down, okay, what's my high and my low, before the thing resets. So do record your data consistently, and this is for 14 days. And this is accessible to you too, so don't worry that you're going to have to, where am I going to find that? Well, it's in your course, okay? So 14 days at 2 entries per day, 28 entries total. Record your date, temperature manually daily at convenient times, AM and PM. Or you can program a USB compatible device for a sampling twice daily, preferably 12 and 12 p.m., 12 a.m., 12 p.m. So there's your median earth temperature lab. Now, we're also going to have, starting tomorrow, from 9 to noon, up at 8 Columbine in the Rattlesnake, we're going to have a multidisciplinary lab. So there's going to be a solar application, geothermal, earth battery, and then we're working on actually having a graphene generator there too. So we'll talk more about how that works in our lab. They're finding that in desalination. Well, actually, let's see if we can take a look at that real quick.